What if? Serious scientific answers to absurd hypothetical questions by Randall Munro, the creator of XKCD. Disclaimer: do not try any of this at home. The author of this book is an internet cartoonist, not a health or safety expert. He likes it when things catch fire or explode, which means he does not have your best interests in mind. The publisher and the author disclaim responsibility for any adverse effects resulting directly or indirectly from information contained in this book. Introduction. This book is a collection of answers to hypothetical questions. These questions were submitted to me through my website, where, in addition to being a sort of Dear Abby for mad scientists, I draw XKCD, a stick figure webcomic. I didn't start out making comics. I went to school for physics, and after graduating, I worked on robotics at NASA. I eventually left NASA to draw comics full time, but my interest in science and math didn't fade. Eventually, it found a new outlet, answering the internet's weird and sometimes worrying questions. This book contains a selection of my favorite answers from my website, plus a bunch of new questions answered here for the first time. I've been using math to try and answer weird questions for as long as I can remember. When I was 5 years old, my mother had a conversation with me that she wrote down and saved in a photo album. When she heard that I was writing this book, she found the transcript and sent it to me. Here it is, pronounced verbatim from her 25-year-old sheet of paper. Randall, are there more soft things or hard things in the house? Julie, I don't know. Randall, how about in the world? Julie, I don't know. Randall, well, each house has 3 or 4 pillows, right? Randall, Julie, right. And each house has about 15 magnets, right? Julie, I guess. So 15 plus 3 or 4, let's say 4 is 19, right? Julie, right. So there are probably about 3 billion soft things and 5 billion hard things. Well, which one wins? Julie, I guess hard things. To this day, I have no idea where I got 3 billion and 5 billion from. Clearly, I didn't know how numbers work. My math has my math has gotten a little better over the years, but my reason for doing math is the same as when I was 5. I want to answer questions. They say there are no stupid questions. That's obviously wrong. I think my question about hard things and soft things, for example, is pretty stupid. But it turns out that by trying to thoroughly answer a stupid question can take you to some pretty interesting places. I still don't know whether there are more hard things or soft things in the world, but I've learned a lot of other stuff along the way. What follows me are my favorite parts of that journey. Randall Munro. What if? Global windstorm. What would happen if the Earth and all terrestrial objects suddenly stopped spinning but the atmosphere retained its velocity? Andrew Brown. Nearly everyone would die. Then things would get interesting. At the equator, Earth's surface is moving at about 470 meters per second, a little over 1,000 miles per hour, relative to its axis. If the Earth stopped and the air didn't, the result would be a sudden 1,000 mile per hour wind. The wind would be highest at the equator, but everything else living between 42 degrees north and 42 degrees south, which includes about 85% of the population, would suddenly experience supersonic winds. The highest winds would last only for a few minutes near the surface. Friction with the ground would slow them down. However, those few minutes would be long enough to reduce virtually all human structures to ruins. My home in Boston is far enough away north to just be barely outside the supersonic wind zone, but the winds there would still be twice as strong as those in the most powerful tornadoes. Buildings from sheds to skyscrapers would be smashed flat, torn from their foundations, and sent tumbling across the landscape. Wind would be lower near the poles, but no human cities are far enough from the equator to escape devastation. Longyearbyen, on the island of Svalbard, Norway, the highest latitude city on the planet, would be devastated by winds equal to those in the planet's strongest tropical cyclones. If you're going to wait it out, one of the best places to do it would be Helsinki, Finland. While its high latitude above 60 north wouldn't be enough to keep it from being scoured clean by the winds, the bedrock below Helsinki contains a sophisticated network of tunnels, along with a a subterranean shopping mall, hockey rink, swimming complex, and more. All those years, you made fun of us for living in such a cold and dark place. It's fine, Norina, sucker. She dies right now. No buildings would be safe. Even structures strong enough to survive the winds would be in trouble. As comedian Ron White said about hurricanes, it's not that the wind is blowing, it's what the wind is blowing. Say you're in a massive bunker made out of some material that can withstand 1,000 per hour winds. And then this 49 the 92nd little pig built a house out of depleted uranium. And the wolf was like, dude, that's good and you'd be fine if you were the only one with a bunker. Unfortunately, you probably have neighbors, and if that neighbor has upwind of you has a less well anchored bunker, then your bunker will have to withstand 1,000 per hour impact by their bunker. The human race wouldn't go extinct. In general, very few people above the surface would survive. The flying debris would pulverize everything that wasn't nuclear hardened. However, a lot of people below the surface of the ground would survive just fine. If you were deep below in a basement, or better yet, in a subway tunnel, when it happened, you would stand a good chance of surviving. There would be other lucky survivors. The dozens of scientists and staff at the Amsterdam Scott Research Station at the South Pole would be safe from the winds. For them, the first sign of trouble would be the outside world has suddenly gone silent. The mysterious silence would probably distract them for a while, but then someone would notice something even stranger. The sun isn't moving. Oh, the Earth must have stopped moving, destroying everything in a global tempest. I hate it when that happens. I'll kick it and see if it starts again. The air. As the surface winds died down, things would get weirder. The wind blast would translate to a heat blast. Normally, the kinetic energy of rushing wind is small enough to be negligible, but this would not be normal wind. As it tumbled to a turbulent stop, the air would heat up. Over land, this would lead to scorching temperature increases, and in areas where the air is moist, global thunderstorms. At the same time, winds sweeping over the oceans would churn up and atomize the surface layer of the water. For a while, the ocean would cease to have a surface at all. It would be impossible to tell where the spray ended and the sea began. Oceans are cold. Below the thin surface layer, they're a fairly uniform 4 degrees Celsius. The tempest would churn up cold water from the depths. The influx of cold spray into superheated air would create a type of weather never before seen on Earth, a rolling mix of wind, spray, fog, and rapid temperature changes. This upwelling would lead to blooms of life as fresh nutrients flooded the upper layers. At the same time, it would lead to huge die offs of fish, crabs, sea turtles, and animals unable to cope with the influx of low oxygen water from the depths. Any animal that needs to breathe, such as whales and dolphins, would be hard pressed to survive in the turbulent sea interface. The waves would sweep around the globe, east to west, and every east facing shore would encounter the largest storm surge in world history. A blinding cloud of sea spray would sweep inland, and behind it, a turbulent, roiling wall of water would advance like a tsunami. In some places, the waves would reach many miles inland. The windstorms would eject huge amounts of dust and debris into the atmosphere. At the same time, a dense blanket of fog would form over the cold ocean surfaces. Normally, this would cause global temperatures to plummet, and they would, at least on one side of the Earth. If the Earth stopped spinning, the normal cycle of day and night would end. The sun wouldn't completely stop moving across the sky, but instead, the sun wouldn't completely stop moving across the sky, But instead of rising and setting once a day, it would rise and set once a year. Day and night would be 6 months long each, even at the equator. On the day side, the surface would bake under the constant silence, while on the night side, the temperature would plummet. Convection on the day side would lead to massive storms in the area directly beneath the sun. If the old day and night cycle is gone, when can I feed these gremlins? In some ways, the Earth would resemble one of the tidally locked exoplanets commonly found in a red dwarf star habitable zone, but a better comparison might be a very early Venus. Due to its rotation, Venus, like our stopped Earth, keeps its face pointed towards the sun for months at a time. However, its thick atmosphere circulates quickly, which results in the day and night side having about the same temperature. Although the length of the day would change, the length of the month would not. The moon hasn't stopped rotating around the Earth. However, without the Earth's rotation feeding it tidal energy, the moon would stop drifting away from Earth as it is slowly doing currently, and would start to slowly drift towards us. In fact, the moon, our faithful companion, would act to undo the damage Andrew's scenarios caused. Right now, the Earth spins faster than the moon, and our tides slow down the Earth's rotation while pushing the moon away from us. If we stopped rotating, the moon would stop drifting away from us. Instead of slowing us down, its tides would accelerate our spin. Quietly, the moon's gravity would tug on our planet. Hey, Earth, why did you stop? Oh no, Earth, are you okay? Don't be scared, Earth. I can help. I'm here, Earth. Your moon is here. And Earth would start turning again. I will never leave you. I mean, not right away. Although, without the Coriolis force, it's anyone's guess which way they would spin. See leap seconds for an explanation of why this would happen. Relativistic baseball. What would happen if you tried to hit a baseball pitched at 90% the speed of light? Ellen McManus. Let's set aside the question of how we got the baseball moving that fast. We'll suppose it's a normal pitch, except in the instant the pitcher releases the ball, it magically accelerates to zero point 0.9 c. From that point onwards, everything proceeds according to normal physics. The answer turns out to be a lot of things, and they all happen very quickly, and it doesn't happen to end well for the batter or the pitcher. I sat down with some physics books, a Nolan Ryan action figure, and a bunch of videotapes of nuclear tests and tried to sort it all out. What follows is my best guess at a nanosecond by nanosecond portrait. The ball will be going so fast that everything else would be practically stationary. Even the molecules in the air would stand still. Air molecules will vibrate back and forth at a few hundred miles per hour, but the ball will be moving at them at 600 million miles an hour. This means that as far as the ball is concerned, they would just be hanging there, frozen. The ideas of aerodynamics wouldn't apply here. Normally, air would flow around anything moving through it, but the air molecules in front of this ball wouldn't have time to be jostled out of the way. The ball would actually smack into them so hard that the atoms in the air molecules would actually fuse with the atoms in the ball's surface. Each collision would release a burst of gamma rays and scattered particles. Nitrogen and oxygen from air fuse with carbon, hydrogen, nitrogen, etc. in ball. Air, nitrogen and oxygen. Ball, carbon, hydrogen, and oxygen. Together, they are fusion. These gamma rays and debris would expand outward in a bubble centered on the pitcher's mound. They would start to tear apart the molecules in the air, ripping the electrons from the nuclei and turning the stadium into an expanding bubble of incandescent plasma. The wall of this bubble would approach the batter at about the speed of light, only slightly ahead of the ball itself. The constant fusion at the front of the ball would push back on it, slowing it down, as if the ball were a rocket flying tail first while firing its engines. Unfortunately, the ball would be flying so fast that even the tremendous force from this ongoing thermonuclear activity explosion would barely slow it down at all. It would, however, start to eat away at the surface, blasting tiny fragments of the ball in all directions. These fragments would be going so fast that when they hit the air molecules, they would trigger two or more rounds of nuclear fusion. After about 70 nanoseconds, the ball would arrive at home plate. The batter wouldn't even have seen the pitcher let go of the ball, since the light carrying that information would arrive at about the same time as the ball. The collisions with the air would have eaten the ball away almost completely, and now it would be a bullet shaped cloud of expanding plasma, mainly carbon, oxygen, hydrogen, and nitrogen, ramming into the air and triggering more fusion as it went. The shell of X rays would hit the batter first, and a handful of nanoseconds later, the debris cloud would hit. When it would reach the home plate, the center of the cloud would still be moving at an appreciable fraction of the speed of light. It would hit the bat first, but then the batter, plate, and catcher would all be scooped up and carried backward through the backstop as they disintegrated. The shell of the X-rays and superheated plasma would expand outward and upward, swallowing the backstop, both teams, the stands, and the surrounding neighborhood, all in the first microsecond. Suppose you're watching from a hilltop outside the city. The first thing that you would see would be a blinding light, far outshining the sun. This would gradually fade over the course of a few seconds, and a growing fireball would rise into a mushroom cloud. Then, with a great roar, the blast wave would arrive, tearing everything apart and shredding houses. Everything within roughly a mile of the park would be leveled, and a firestorm would engulf the surrounding city. The baseball diamond, now a sizable crater, would have been centered a few hundred feet behind the former location of the backstop. Major League Baseball Rule 6.08b suggests that in this situation, the batter would have been considered hit by pitch and would be eligible to advance to first base. Spent fuel pool. What if I took a swim in a typical spent nuclear fuel pool? Would I need to dive to actually experience a fatal amount of radiation? How long could I stay safely at the surface? Jonathan Bastien Filatron. Assuming you're a reasonably good swimmer, you could probably survive treading water from anywhere to 10 to 40 hours. At that point, you would black out from fatigue and drown. This is also true for a pool without nuclear fuel in the bottom. Spent fuel from nuclear reactors is highly radioactive. Water is good for both radiation shielding and cooling, so fuel is stored at the bottom of pools for a couple of decades until it was inert enough to be moved into dry casks. We haven't really agreed on where to put those dry casks yet. One of these days we should really figure that out. Here's the geometry of a typical fuel storage pool. The heat wouldn't be a big problem. The water's temperature in a fuel pool can in theory go as high as 50 degrees Celsius, but it's generally between 25 and 35 degrees Celsius, warmer than most pools but cooler than a hot tub. The most highly radioactive fuel rods are those recently removed from the reactor. For those kinds of radiation coming from spent nuclear fuel, every 7 centimeters of water cuts the amount of radiation in half. Based on the activity levels provided by Ontario Hydro in this report, this would be the region of danger for fresh fuel rods. Swimming to the bottom, touching your elbows to a fresh fuel container, and immediately swimming back up would probably be enough to kill you. Yet outside the outside boundary, you could probably swim around as long as you wanted. The dose from the core would be less than the normal dose you get from walking around. In fact, as long as you were underwater, you would be shielded from most of that normal background dose. You may actually receive a lower dose of radiation treading water in a spent fuel pool than walking around on the street. Remember, I am a cartoonist. If you follow my advice on safety around nuclear materials, you probably deserve whatever happens to you. That's if everything goes as planned. If there's corrosion in the spent fuel rod casings, there may be some fission projects in the water. They do a pretty good job of keeping the water clean, and it wouldn't hurt you to swim in it, but it's radioactive enough that it wouldn't be legal to sell it as bottled water. We know spent fuel pools can be safe to swim in because they're routinely serviced by human divers. However, these divers have to be careful. On August 31st, 2010, a diver was servicing the spent fuel pool at the Lebstadt nuclear reactor in Switzerland. He spotted an unidentified length of tubing at the bottom of the pool and radioed his supervisor to ask what to do. He was told to put it in his tool basket, which he did. Due to the bubble noise in the pool, he didn't hear his radiation alarm. When the tool basket was lifted from the water, the room's radiation alarms went off. The basket was dropped back in the water and the diver left the pool. The diver's dosimeter badges showed that he received a higher than normal whole body dose, and the dose in his right hand was extremely high. The object turned out to be protective tubing from a radiation monitor in the reactor core, made highly made highly radioactive by neutron flux. It had been accidentally sheared off while a capsule was being closed in 2006. It sank to a remote corner of the pool where it had sat unnoticed for 4 years. The tubing was so radioactive that if he tucked it into a tool belt or in a shoulder bag where it sat close to his body, he could have been killed. As it was, the water protected him, and only his hand, a body more resistant to radiation than the delicate internal organs, received a heavy dose. So, as far as swimming safety goes, the bottom line is that you'd probably be okay, as long as you didn't dive to the bottom or pick up anything strange. But just to be sure, I got in touch with a friend of mine who works at a research reactor and asked him what he thought would happen to someone who tried to swim in their radiation containment pool. In our reactor, he thought about it for a moment. You die pretty quickly before reaching the water from gunshot wounds, which is too bad. It'd make a hell of an energy drink. Weird and worrying questions from the what if inbox. Number 1. Would it be possible to get your teeth to such a cold temperature that they would shatter upon drinking a cup of hot coffee? Shelby Herbert. Thank you, Shelby, for my new reoccurring nightmare. How many houses are burned out in the United States every year? What would be the easiest way to increase that number by significant amounts? I say at least 50%. Anonymous. Hello, police. I have this website where people submit questions.